Picking back up, finishing up lesson 2.2, we just did this example. We were asking the question, at f prime of 0, do we even have a derivative existing? If not, would there happen to be a cusp? Well, we used our shortcut, our power rule. You could see that if we did plug in f prime of 0, actually we're not going to exist. You can see that you can't divide by 0. But the big question is, of course, do we have a cusp? Well, let's take a look as we approach 0 from the right on our derivative. Remember, approaching 0 on the right means that we're plugging in positive values very close to 0, very small ones. The 1/5 power down below is actually a 5th root. Suffice it to say, everything in this expression would be positive. We'd have something very tiny down below. 1 over small is big. Everything is positive. We're going to positive infinity. If by way of comparison we were approaching 0 from the left, well, we'd be plugging in values like negative 0.001. Now immediately in a 5th root, you need to remember that negatives are okay. In even indexed roots, you can't have a negative plugged in, but here we can. And in fact, if I gave you, say, maybe one of the most famous 5th roots, like the 5th root of 32, what number times itself 5 times is 32? That would be a 2. Well, look, if I took the 5th root of negative 32, that would just be negative 2. So plugging in negative values into 5th roots, you get a negative. You get something very tiny, you get negative infinity. What are we really saying? We have different directions here. There is a cusp at x equals 0. And that's all we wanted to finish talking about.